Hello everybody and welcome back to another exciting scheduled class for Psych 1A. In today's class we are going to be talking about the topic of memory and how other topics within this field of memory have been studied over the years. First we're going to talk about what memory is about, and then we'll talk about how we can improve and how we can recognize problems with our memories. When we discuss this area of memory, I do want you to recognize that again, in this class we are going to be revisiting a very specific branch of psychology that we call cognitive psychology. Memory is just one of many, many parts of cognitive psychology that are out there. In the last class we talked about the area of perception, which also fits into this realm, or this definition of cognitive psychology. In cognitive psychology in general, what we're doing is studying what's called internal mental processes. So how your mind organizes, makes sense, and works with the information that's embedded within it. In addition to talking about memory and perception, though, cognitive psychologists can study a number of other topics that involve this internal mechanism. Intelligence, how our brains organize, make sense, and interact with things, is another topic we can explore. Language, which we'll discuss a little bit more about when we get into development, is another area that cognitive psychologists are interested in. Thinking and problem-solving skills are two very big areas that we look at in cognitive psychology, and our ability to multitask and do other types of attentional actions is another branch of cognitive psychology that's out there. But instead of talking about all of these areas for just a few seconds, in today's class, again, we're going to focus in on the area of memory because there's a lot of research that's looked at that specific area. When we talk about memory, what we have to do is address it in a series of different steps. What I'd like to do in today's class to introduce you to the idea of memory is talk about where it all started, namely the first person to do research in this particular field. But after we've talked about where psychology started in the field of memory, we want to then go on to different types of memory tests and different types of memory theories that are out there today. And when we get through this class, we will be better prepared to understand and appreciate some of the subtle nuances to our memory that most of us aren't aware of until we actually encounter problems with them. But again, before we get to all that, we're going to start with where it all began, and that's with a man named Hermann Ebbinghaus. Ebbinghaus is credited for being the first psychologist to study memory because theoretically he was the first person to actually come up with a way to scientifically gain evidence and information about it. Before Ebbinghaus, there were many, many people interested in the topic of memory. Philosophers debated for centuries what memory was most like. Some equated it to something like a bathtub, where you could continue filling it to a point, but once you had too much, information would start to spill out, or it wouldn't be able to contain it. In the 16th, 17th, and 18th century, people started relating relating our memory to something like a machine or a mechanical engine that required energy, sustenance, and was constantly moving, building, and adding. There are many, many analogies that have been created over the years to try to help us better understand the topic of memory. Ebbinghaus sort of liked the idea of talking about models, but what he was really interested in is not necessarily how it overall works, but what we can actually do with it. What he sought out to do was come up with an understanding of not only the limitations, but also the abilities that we have when we talk about this idea of memory. So he created very, very structured experiments that allowed him to get at what memory was all about. And to make sure that he didn't have any weird data or any problems, he decided to study this particular topic on only one subject, namely himself. So what he did was, for almost a decade, study many, many pieces of information in order to try to remember as much as he could and test what he actually forgot. In these study experiments, what he would do is try to memorize something he went on to call nonsense syllables. 3 to 4 little letter syllables that meant nothing on the surface, that had no at least true meaning in his language. This idea allowed him to essentially create hundreds of different nonsense syllables that he would test himself on each single day in different ways in order to understand all the different parts to memory and how it actually worked. Now, to test this idea of memory, what Ebbinghaus tried to do was create two different types of information, or test two different pieces of information. The first thing he was interested in is something he called learning curves, namely how well our brain could take in information from our environment. So what he would do is sometimes read small lists, see how much he could learn. Sometimes he would read large lists, see how much he could learn. More often than not, though, what he was interested in was how many times he needed to expose himself to information, or how long he needed to expose himself to information before he was able to retain a certain amount of that information. So in one test, he might read a list of 10 words once, see how many of those 10 he remembered. Then he would read it a second time, see how many of those 10 he remembered, a third time, a fourth, fifth, until he got to perfect retention of that information. This idea allowed him to create a number of what was called learning curves based on different situations and environments that he exposed himself to. But in addition to looking at how the information was obtained, he also wanted to know how the information would actually leave the brain after it had been there. So what he was also interested in creating was something called forgetting curves. Sometimes he would look at information that he was just presented. So he would read a list and ask himself to wait for 5 seconds and see how many of those words from the list he would retain. Other times he would read a list and maybe say wait a minute and see how many he'd retained. Third time he might say wait 20 minutes after reading a list to see how long it was retained. And by varying this amount of time between when he read something and when he was tested on something, he could see, generally, how quickly information would leave his brain. Sometimes he would also try to memorize information. So he would learn a list of, say, 15 words and test himself at longer intervals to see how long it would take for that memorized list of 15 words to completely leave his head. These types of tests were ingenious because it essentially gave us our first trick, or our first technique, that other researchers could use to study this general idea of memory. And after coming up with these tests, many psychologists became inundated with this need to try to replicate what Ebbinghaus had done. And what lots of them also wanted to do was try to perfect his method. To understand how his method might be flawed, though, what I thought we'd do is just replicate one of Ebbinghaus's basic experiments. So what I'm going to do on the next slide is read you a list of words. And what I'd like you to do is pause for a couple seconds after I read the list, and then after I give you the instructions to do so, write down that list. If you haven't collected a sheet of paper right now to write down a list, please pause this presentation so when we get to the next slide and the list of words is read to you, you'll be prepared and you don't have to sprint off and try to grab something in the middle of the list. Please, again, pause now, and we'll move on to the next slide with the actual list. Okay, here's the list. Bem, Pab, Fup, Gom, Hux, Sizz, Vab, Cag, Hin, Wef, Nim, Mep, Rud, Tig, Dev. Now I'd like you to write down as many of those nonsense syllables as you can. Give you a few more seconds. Okay, here's that list again, so you can check whether or not you memorized all of them correctly, or you identified them correctly. Bem, pab, fup, gum, hux, siz, vob, cag, hin, wef, nim, mep, rud, tig, and dev. Now, this activity is very similar to what Ebbinghaus was doing time and time again. And again, the reason why psychologists are so enamored with Ebbinghaus's work was that he had nothing to go off of when he came up with these types of tests. His ideas were truly novel, and they gave us a path to follow when we wanted to start studying this idea of memory. Essentially, he created the first systematic approach to understanding this thing that had baffled us for many centuries. But when looking at this from a slightly more critical perspective, what lots of psychologists quickly realized was that even though it might help overcome some of the problems that we have with memory research, by being so structured and consistent in his approach, he might be missing some of the key elements to memory. He might not be able to test memory in its true form. In fact, a number of people have said that when we try to talk about memory, we need to try to appreciate the fact that it can be reproduced in a number of different ways. The tests given, the request to reproduce information in different ways, can have a dramatic effect on what we're capable of recalling and what we're not capable of recalling. Another thing that researchers have later argued was that what Ebbinghaus was looking at was just basic curves that we relate to memory. Most people nowadays feel, though, that our brain is not on this curvilinear relationship. Instead, they argue that we actually have different types of memory that we need to address. Now, this is definitely not an argument that's been settled. There's some psychologists that believe that Ebbinghaus was exceptionally accurate in his approach. But there is a lot of research to support the notion that maybe memory is slightly more complex than what Ebbinghaus had proposed in his research. Another big problem we see with this research is that Ebbinghaus was only interested in whether or not he got something right or not. In reality, when we look at memory, when we look at how it makes sense, oftentimes what we're intrigued by is not what you can recall accurately, but what you distort or what you can't actually recall. And all of these problems and bonuses to Ebbinghaus's research has led us on a number of different paths to better understand this topic of memory, even though almost all research stemmed from this original idea that Ebbinghaus had formed. One of the first things we can address when talking about where memory went after Ebbinghaus's work was how we revised and added extra tests to understand the field of memory. Since Ebbinghaus's work, we've now defined his particular approach as something called a free recall test. Namely, when I read you lists of words and ask you to reproduce them out of thin air without any aids, any help, your memory is entirely dependent, or your ability to display memory is entirely dependent upon you reproducing that information without any help or crutch whatsoever. But what lots of researchers have since found is that when we provide extra information, cues or sources, then memory can be much richer and it can have much more information in it that we're not able to display by just using this free recall task. A classic example of this is through something called a cued recall test. One of the more classic ones that people will ask is one that you see on the next slide. In cued recall tasks, what we can do is add information to free recall questions that might be asked. So what you see here in this first slide is an example of a free recall task. If I asked you to name the author of all of these textbooks, Moby Dick, Emma, the Sherlock Holmes stories, the textbook for this class, Origin of Species, other famous books primarily written in English. I apologize. These particular authors might be hard for you to come by. In fact, I'd be very surprised if anybody in this class were capable of knowing, or I guess recalling, more than 3 authors in this entire list. But if I change things up and make this a cued recall task by adding the author's initials to these books, so their first and last name, the very first letter in both of them to this, what you might be able to do is recall these authors' names much, much better. So even though Moby Dick might have been hard for you to recall the author of it in the beginning, seeing HM might lead you to say, oh, that's right, I remember the name now. It's Herman Melville. You might not be able, with many, many extended days, to pop that name in your head on your own. But the initials, this cue that we have, can allow our brains to access that information in a way that we didn't actually have the ability to discover in that free recall task. Now, another type of test of memory that we've come up with since Ebbinghaus's work is something that all of you are probably exceptionally familiar with. In fact, you will be tested on this for our exams. It's something we call a recognition test. When we're testing recognition, we're not giving you hints as to what the answer could be, or hints to kind of lead you to the answer, but instead we're actually giving you the correct answer embedded within other correct answers to see how well you can actually identify them. And when we've given recognition tests, what we found as memory researchers is that your memory can greatly improve, or at least your indication of your memory can greatly improve. If you want an example of this, for those of you that are familiar with Snow White and the Seven Dwarfs, the classic story, I'd like you to try to remember the name of the 7 dwarfs. I'm guessing most of you are not doing so hot with that. In fact, I'm guessing it's extremely challenging for a number of you that haven't seen it in a number of years. You probably can remember a couple, maybe 3 or 4. But that particular task might not be indicative of how much memory you actually have of them. If I were to give you a recognition test, we might find something very different. If I were to instead ask you to simply identify the name of the 7 dwarfs, I'm guessing most of you should be pretty good at this particular task. Now, if you've never seen Snow White and the 7 dwarfs, you won't do any better in this recognition task than you would if I gave you the free recall test. But if you had any traces of memory whatsoever of this experience, performing this recognition task should help you identify a name or two that you might have forgotten. So people like Doc, one that some of you might have never heard of or remember after all those years, would come screaming back to you. Somebody like Bashful, another less memorable one, but a dwarf nonetheless, is another name that might come to your mind when you see the actual list. And this is what we found in numerous experiments over the years. When people are asked to just recall something out of thin air, it's very difficult to do. But when given the right prompts, we can see that those memory traces are there much longer than we think, and in much milder but nonetheless existent forms many times after we would expect that information to have left. Now, there is one other major type of general memory test that is really interesting to researchers. It's one that we've just started looking at in the last couple decades. It's something we call a savings test. And savings tests don't actually look at what we can identify to begin with, but instead we can test memory, but how well somebody can memorize stuff at a later point. So in a savings test, what we're looking for is if you've learned something at some point in time in your life. An example of this could be something like people being able to identify the entire periodic table. What we see in numerous studies is that some students in their junior highs or high schools are forced to memorize all of the elements in the periodic table, while others are not. And as kids move on, what we often see is that most of the time, unless a child actually gets into chemistry, there's very little difference in the ability to, on the spot, identify where the elements in the periodic table are when we compare a person that learned it to somebody that's never had to actually memorize this. But something really interesting occurs when we ask both groups of individuals to learn the periodic table. The ones that actually have a past memory of it will do much better at relearning the periodic table than those that have never learned it before. In fact, even though some people might not remember having done something, what oftentimes will happen is if they've done it in their past, they can learn that behavior or learn that piece of information much more quickly than somebody that's never actually done it before. And this savings test is one that really baffles a lot of memory psychologists because it implies that even if you don't consciously remember something, even with large numbers of hints, somehow your brain seems to be almost hardwired to be able to access that information or be able to learn that information much more easily than it could if it had never been presented that information before. Another type of test that we actually have come up with doesn't test explicit memory, but instead it tests a different type of memory that people have. We'll discuss different types of memory in much more detail in a few minutes, but this particular one is interesting because of how unusual it is in comparison to the other sources of memory that we've talked about so far. What we see with implicit memory is that sometimes we can test people's memory not of what they can articulate, but instead we can test the memory of people that relates to information that they just naturally respond to or react to. The problem with implicit memory is the fact that it oftentimes overlaps with explicit memory. If I ask you to, say, learn how to ride a bike, you're probably going to have implicit memory of how to ride a bike. But at the same time, you'll also explicitly remember learning how to ride a bike. So many researchers have tried to find over the years are special individuals that actually do have separate systems for their implicit and explicit memories. What we've found over the years is that even though most people do not have the ability to differentiate between their implicit and explicit memories, there is a small group of people who experience something called anterograde amnesia that actually have major problems with their explicit memories, but still have fully functional implicit memories most of the time. And what this will allow them to do is form new implicit memories while still struggling, or actually completely being incapable of forming new explicit memories of any events that occurred after the damage that they've experienced. Now, usually this damage involves some type of trauma to an area of the brain called the hippocampus. And when people suffer with anterograde amnesia, it can be very frustrating because essentially they're incapable of ever forming new memories of all of the stuff they're experienced. What we found, though, in these individuals is that even though they can't remember things, they do have implicit memory. And the way we test this is through a number of different techniques that are out there. One technique that we do is one that you see pictured in front of you. What we'll ask individuals to do in this test is trace a star. But we don't just have them trace a star by looking at and following it. Instead, what we do is we set up an apparatus like the one you see above. There's a cardboard piece placed over the star, so the individual trying to trace the star can't see directly down on it, but they can see the star through a mirror. Now, if anybody tries to do this task, the very first time they try, they almost always struggle mightily with this task. It's very difficult to actually do. In fact, people with or without anterograde amnesia are usually very, very bad at this particular test the first time they do it. But what's really interesting to researchers is that this particular task is something we can learn fairly quickly. essence, our implicit memory can improve greatly for this test after a couple times that we do it. But for normal individuals, again, it's impossible to separate the explicit from the implicit. If you come into a lab, take this test, trace the star one time, and do really poorly at it, we might say you didn't do well, please come back the next day. The next day you come back and you remember having taken this test. You remember and can articulate some of the rules that you've sort of learned as to how to improve on this test. Yes, theoretically your body is learning as well, but it's impossible for us to tease what's going on in your head from what's going on in your body, or I guess in the processes between your mind and your body that's allowing you to do better at this. But for people with anterograde amnesia, this isn't the case. When they come in on the first day and they're asked if they've ever done this, they'll, because they have actually never done this, say no, sit down and do just as poorly as you on the test on the first day. On the second day when they come back, this is where it gets interesting. Because when we ask them if they've done it before, people with anterograde amnesia, because they can't form new memories, will say no, they've never done it before. And we sit them down and have them trace the star, and something interesting happens. Even though they don't physically remember having done it, their body shows memory. In essence, it shows implicit memory of having done this task before. So they improve just as much as a person with normal memory. This happens on the third day, fourth day, and by the fifth or sixth day, they're performing this star tracing task almost perfectly, even though none of them remember having done this task before. Anterograde amnesia is something that's exceptionally rare, so we still haven't mastered our understanding of it, even though Hollywood does like to talk about it. One of the classic movies that just came out a little while ago is a movie called Memento, which actually is a story depicting what the life of a person with anterograde amnesia might be. And what we see in these types of experiences in movies is that it's a very interesting thing. But unfortunately, as interesting as it is, it's very debilitating and frustrating for the people experiencing it. And more often than not, most people who experience damage to this region do not survive for either very long or do not survive at all. So we don't know much about it, but in the case studies that we have, we do know that indeed people have a different type of memory that we call implicit memory. And it's another thing that we can test in different ways since Ebbinghouse's original research. Now, what these tests show us is that when we're talking about memory, it is extremely diverse. It's not a very simple mechanism that can easily be studied by just looking at lists and assuming that everything we know about list memory can relate to everything that exists in memory. And this idea has led a lot of researchers to not necessarily ask about different tests, but different types of memory that can exist. One of the major ways that current researchers classify memory is in terms of something that we call temporal categories. Temporal categories in this case deal with when information is presented and tested later on. So if I present you an informational piece, say some external event or something that you think in your head, I can test that memory either immediately, a few seconds after, maybe a few days after, or even months or years after you've experienced that particular stimulus. And when I test you is theoretically allowing me to look at different temporal stages of memory that you can have. Most researchers now believe that our temporal stages can be broken down into three different parts. The first part of memory we have is something called sensory memory. This sensory memory, though, is one that's a little bit more debated than some of the other ones that we're going to discuss. One of the reasons why sensory memory is something that's so unbelievably debated is the fact that a large number of individuals believe that sensory memory could theoretically be infinite. And what it is a short type of memory that allows us to actually process and briefly remember every single stimulus we're being presented at any given moment in time. Now, to appreciate that, you have to think of all the things that you're experiencing at every single moment in time. If you're sitting on a chair or couch right now, you're feeling the pressure of that chair on your back, on your bottom, on your legs. You're feeling your feet pressed against something. You're probably feeling the ambient temperature in the air. And that's just what you're feeling for sure. Your arms are probably touching something. There's probably some type of sound outside of mine that you're hearing. You hear my voice, I'm hoping. You see all the different stimuli in your environment. You've got your own thoughts. You're experiencing different smells. All of this stuff is happening at any given moment in time. And what sensory memory researchers propose is that you remember every single one of those things. But here's the catch. It only lasts for a fraction of a second. Less than a half a second will pass, and you'll lose all of that information except for the stuff that you deem most relevant. This is what sensory memory psychologists believe exists, and it's something that has been very tough to prove over the years. But one particular researcher, his name was Charles Sperling, has actually come up with a study to show how we might actually prove that sensory memory not only exists, but it is indeed infinite. What Sperling did in his test was kind of cute. He would have students sit down, look at a screen like you see on the left. They would flash letters and numbers, and that screen would be flashed for a very, very short period of time. In the first set of experiments, he would flash the letters and numbers for a hundredth, actually a 20th of a second, and quickly after that asked people to identify as many letters and numbers as they could remember. In the first part of the task, what he found was not that positive of a result. In essence, when people were asked to try to identify it, within a half second after writing everything down, most people could only remember at most somewhere between 4 to 6 items. Lots of people looking at Sperling's results argued that, look, he had proven that sensory memory indeed is not infinite. But Sperling wasn't quite finished. He wanted to show that it was indeed infinite, but instead what was going on here was in that half a second, a large portion of the information that we had memorized had already been forgotten. So he tweaked the experiment a little bit. What he then did was he paired tones with each of the rows. So a high tone was paired with the top row, a medium tone was paired with the middle row, and a low tone, a very deep tone, was paired with the bottom row. So he would flash these letters for a 20th of a second, and then immediately after, almost seemed instantaneous to the participants, one of these three tones would play. And people would be asked not to identify all the letters in this case, but just the letters associated, letters and numbers that is, with the row that they actually had been, or the row that was affiliated with the tone that they had heard. So flashing it up, in this case on the example, these letters and numbers, medium tone plays, and therefore the person has to recall the four letters in the middle, LJ68. And by doing this, Sperling found something really interesting. Even though nobody was able to recall all 12 of these letters and numbers when they were tested with all of them, the first second he added this tone, people, after a few training experiences, were almost always able to recall all four of the numbers and letters that they were asked to identify. And what Sperling argued, and many sensory memory psychologists argued the same, is that what he proved here was that at some point in time, each of us actually had a trace of memory that involved all 12 of the numbers and letters that we saw in front of us. It was just we forgot them too quickly. So when asked to write them down, by the time we got to number 6, those remaining ones had already disappeared and our sensory memory had moved on to something else. Now, some people don't believe that this is all we need for proof that sensory memory exists, but a big percentage of memory researchers now accept that sensory memory is the first threshold into memory. But when we talk about really testing memory, the next stage of memory, or sensory memory transfers into, is one that lots of psychologists are really enamored with. This stage of memory is something we call short-term memory. And it's the memory of information that we deemed worth paying attention to. Now, unlike sensory memory, most people studying short-term memory argue that this particular stage of memory is extremely limited. They propose that people actually only have the ability to remember something called 7 plus or minus 2 items. That means when testing your memory on any piece of information, usually you're only able to remember somewhere between 5 and 9 of those items, but more often than not, almost exactly 7 of those items. Now, originally when people were testing this, what they would use was lists. So I would read you words and see how many of those words you were able to remember. Now, if you weren't able to remember those 7 nonsense syllables, don't worry, you're not alone. In fact, very few students actually remember 7 nonsense syllables from that Ebbinghaus test. But if I tested you time and time again, and you got used to it, 7 would be about the number that most of you settled on. In fact, that was the number Ebbinghaus settled on in his experiments. But what lots of researchers have since found, in particular one researcher named Alan Baddeley, is that when we're talking about the storage capacity of this particular stage of memory, what we often see is that this capacity not only involves oral things, so words we hear or speak, but other parts of our senses as well. So if we see something spatially located somewhere, or we have some type of sound that we're hearing, all of those things can actually take up capacity in our memory. What lots of researchers now talk about is something called a working memory instead of a short-term memory. Because like Alan Baddeley, other researchers believe now that when we're talking about the short term, we're talking about not only the things that we're experiencing, but things from our past, and organizing, coordinating all the different senses and pieces of information that we want to make sense of. So unless you're just trying to memorize a list of words, your capacity for 7 plus or minus 2 items can be taken up considerably by a number of things that don't have anything to do with what you're being presented. Maybe you've got some fight that you've had with your roommate in the back of your mind as you're trying to learn something in school. Well, that's one item that you have to attend to. Maybe you also have to remember your locker combination at the gym that you're going to right after. So that's another item that's in your working memory temporarily. If we can get inundated with pieces of information, we can start to realize that it might be tough to remember anything that we're being presented because we're so attentive to other things that are going on in our environment. Nonetheless, no matter how distracted you are, what we see is that if we add up everything you have, this storage capacity gets to that 7 plus or minus 2 items almost all the time. Now, those items that are in there, though, can either be there for a long time or a short time. Most researchers believe that if something gets into short-term memory, but we don't deem it very relevant, that information will disappear within a matter of seconds. In fact, some researchers say if we don't really attend to something and find it important, within 10 seconds it'll be completely gone. Some people believe, though, that we could have traces of memories up to a few days, even if we don't necessarily need to attend to. Sorry, I'm back. Some researchers also argue that you might even have some information that's so important that it dominates your memory for a number of years. Now, this type of memory would be something that we now qualify as something called long-term memory, which we'll discuss more in detail. But the idea that something could be there for that long is really interesting to researchers. Another thing that's interesting to researchers is the notion that maybe some of this information just entirely disappears after we decide it doesn't need to be there. But if the stuff we decide needs to be there has to go somewhere, where it will go is our long-term memory, where we can start to process this information at a much deeper level and integrate it with other information that we've experienced in the past. As was mentioned before, when we're looking at long-term memory, we're looking at information that we attended to at some point in time and deemed of use for either that current moment or in the future. And when we're talking about long-term memory, what we often see is that this memory is exceptionally complex, and it's often very highly integrated with other pieces of information that we have. Oftentimes, we also see that long-term memory is exceptionally susceptible to distortions. So if you think back to, say, your high school graduation or your first kiss, most of us probably think that we have a perfect recollection of those events. But oftentimes what we see is that when people are actually compared to others, when they were experiencing the same things, or when we have the rare chance to actually compare a person's memory to a video, what we can see is that this ironclad memory that people think they have is often exceptionally distorted. And we'll talk about why those distortions occur in the next part of class. Before we get to that, we want to talk about one major debate that researchers still are having with this idea of long-term memory. And that's the question of whether or not long-term memory ever leaves our brain once it's in there. Some researchers believe that long-term memory is absolutely permanent. They argue that there might be very subtle traces that we have to use very intricate tests for to get at it, like the savings test. But nonetheless, it's there for good once we've actually learned it. Other researchers aren't quite as sure about this. Some have argued that what might actually be happening is that some information might be kind of getting erased in our heads. This can happen for a couple different reasons. Some people propose that one of the reasons why this is happening is the neurons that are connected in our hippocampus and other regions of our brain to remember that information might actually move or die. And by moving or dying, this idea, this path that we've created, could be completely obliterated. Other researchers have argued that what might be happening is that those cells that are there for a specific memory, if we don't use it enough, might be rewritten. Essentially, we might stamp another memory in that particular neuron path's spot. An example of this would be something like a computer. If you've got information on your hard drive and you delete it, well, you're deleting it, but it's still there until you add more information. You download another computer program or another system. When you do that, that's the time that that information disappears. That could very well be what goes on with memory. We might have that information, we may not use it for a long time, so we send it to the recycle bin, even though theoretically we could access it at some distant point in time. But if we get something new and it rewrites it, then that information could theoretically be completely obliterated. It could be removed from our memory. Fortunately, because we don't have the devices or the ability to follow somebody around for an extended period of time, we don't know if this case is true. If we actually have rewriting, if we have decay and death going on when we talk about specific memories. Of course, we also don't have the ability to say this neuron right here is associated with this particular memory. So maybe in the distant future we'll answer this debate, but right now we just leave it as that. A debate about whether or not something can remain in our long-term memory forever, or it can actually disappear with a lack of use. One additional way that we break down memory is by taking that long-term memory and breaking those memory traces into different types. The content of the information can be qualified in a number of different ways. One major separation that we have with memory, which we've already talked about, is differentiating between what's called explicit memory and what's called implicit memory. Explicit memories are those memories that you can consciously recall, namely the things that you can articulate. Implicit memories are the ones that don't actually involve articulation for you to be able to actually display traces of memory. As I said before, oftentimes it's tough to tease these apart, but if we're talking about examples of implicit memory, basic kinesthetic skills would be an example of implicit memory. So your ability to ride a bike is something that is actually an implicit memory, even though you can probably articulate how to ride a bike. It's your body's memory of this, your body's ability to reintroduce, or I guess re-exhibit those behaviors when you haven't done it for a long time, that is indicative of implicit memory. Another type of implicit memory that we have deals with another type of learning, which we're going to be talking about later, called classical and operant conditioning. Namely, when you encounter some environmental stimulus or some type of person, your body can react to that person differently based on what you've encountered, even though you might not consciously realize that you are behaving differently or that your body's responding differently to that environment or that individual. When that's happening, again, we call it implicit or non-declarative memory. Explicit memories get broken down into one of two categories. Some explicit memories are something we call semantic memories. Semantic memories are just general facts. So if I ask you what the capital of China is, that would be a semantic memory because it's just merely a fact. If I ask you when you learned what the capital of China was, and you could recall the day and the event and the experience that you had, that would be called an episodic memory, something that you actually personally experienced. So again, asking you the name of the first person you kissed, if you kissed somebody, semantic memory. Asking you to recall the event of that kiss, episodic memory. Sometimes there's an overlap between the two. Sometimes there isn't an actual overlap between these when we're recalling specific pieces of information. Many psychologists over the years have tried to see if not only can we qualify these things as different things, but whether or not they existed in different forms in our brain. This debate is still definitely unsettled, but it's another one of the many avenues in memory that current psychologists are discovering and exploring along the way. This marks the end of the first part of class, where we detailed the general idea of memory, how we study it, and some of the major parts to this particular concept. In the next part of class, we're going to be talking about some current research that's looked at what actually goes wrong with our memory. So we'll discuss some of the problems that memory psychologists have recognized with human behavior and memory. And then we'll also talk about some of the solutions that a number of cognitive psychologists have come up with when we talk about how we can actually improve our memory. If you haven't yet, please read those sections before you get to the next part. Take a break as well, because I know this particular class was a little bit longer than some of the other ones. And when you're ready, come back with a sheet of paper so you can write some stuff down and get ready to learn about how to improve your memories and where your memory's going wrong. Take care.